My name is Winston, and I'm a rising sophomore at the Corey Lane School. My project is the ball tracking robot, and I chose it because it included aspects of both computer science and engineering, which are both fields that I'm interested in. So what it does is that it uses color detection to detect this ball, and then it follows it around. So I'll show you the demo right now. So before I show you the demo, I'll let you know how it works. So it has 5 basic movements: move forward, move backwards, move left, move right, and stop. And how it detects the ball, how it tracks the ball is that once the ball is in the frame of the camera, it draws a rectangle around the ball, and it uses the rectangle to get the center of the ball. It takes the x coordinate of the center of the ball and compares it with some values to determine if the robot turns left, turns right, or moves forward. So that's my first function. Another function that I implemented is obstacle avoiding, and it uses these ultrasonic sensors up front to do that. So what it does is that when the sensor detects that an obstacle is in front of it, the robot starts backing up to avoid crashing into it. Another function that I implemented is ball seeking, and it does this when the ball is not in the range of the camera, so it starts rotating continuously to find the ball. So when the ball is out of the range, it starts rotating. The reason why I don't have it rotate faster is so that it doesn't overturn, and because if it overturns, then it makes it harder to find the ball. And once it finds the ball again, it starts following it. One modification that I made was adding 2 LED lights to the back of the robot, and what they do is they signify if the ball has been successfully reached or not. So the red LED shines when the ball is further away, and the green LED shines when the robot has reached the ball. So you can see the red LED is shining until it has reached the ball, and the green LED shines. So So how it runs is that we have a board right here. It's called the Raspberry Pi. And it's basically a computer, and it's the brain of the robot. So what it does is it processes code, and then it sends signals to this motor driver right here. And this motor driver uses these signals to power up the motors, and that's how it changes direction and changes speed. And the ultrasonic sensors up front, as I mentioned before, they are used for the obstacle avoiding function. And what they do is they tell the distance between an object and the robot. They do this by emitting an ultrasonic wave that bounces from the object and back, and it uses the time that it takes for the wave to bounce there and back, and multiplies it by the speed of sound, and it divides it by 2. This is how you get the distance in centimeters. So a challenge I faced during the programming part of the project was getting the turning left and turning right to work, because as I mentioned before, I used the x coordinate of the center of the ball to find it, and I needed to get the areas right of the x coordinate to move left, and move right, and then move forward, and that took a lot of trial and error and troubleshooting. So my next implementation to this project would be to add object identification, so it can detect more objects than just this ball. And that would help with its accuracy, because right now, since it only has color detection, it would detect if it detects the color red somewhere else on the camera, it might track that and sell the ball. So during my time at Bluestamp, it really surprised me how much I could push myself, and I feel like I've learned a lot of valuable skills, such as soldering, wiring, programming, problem solving, and circuitry. I think that Bluestamp has been a really amazing experience for me, and I hope to do more camps like this in the future. Thank you.